Hello boys and girls, this is the second video to the Vienna NEO meetup and we get a little bit more technical this time. For an overview, watch the intro to the first video.
Okay, I am now going to show you examples of contracts in C#. The first one is going to be a very trivial Hello World kind of contract that exemplifies how you would use storage. Storage is, for example, used if you want to implement a token, because a token on the NEO blockchain, really also in Ethereum, is really just storing the amount of the token as a value for some key that is an address. And if you do a transfer, what happens is that you just take some fraction of the amount in the storage associated with one address and put it into another one. So that's essential. And also licensing contracts that associate whatever asset with individuals are implemented in that way that you transfer some information, and transferring really just means that within the context of some contract, you change how data is stored. The NEO languages that are used the most at the moment are C# and Python. We're going to see some Python later, I guess. But for C#, that's really just some simple script. If you know C#, then that's really trivial. If not, then the way smart contracts are structured is that you have some main function here. And if you want to invoke a contract, which means if you want to make a call to the network and want for the virtual machines in the node to execute the contract, then you would make the call possibly with some arguments, and the nodes would execute it, then get a result, and do a consensus round, finding out what should be the output, and that's what you get. And usually some state, namely what's written on the blockchain, is changed, or some additions are made with regards to who is transferring to who and so on. The convention on the NEO smart contracts as it developed is that we pass a string as first arguments, usually called the operation, and then usually a list of other arguments. In these contracts I adhered to the convention in the sense that I pass a string, and then I hard code that I want two additional arguments for this contract to be executed. In this case it's another string and some integer, and depending on what the operation string is, here we will see some if statements. Three different things can happen. If you pass this operation neither the word print, write, read, then it will, in this case of this contract, just return a default return value, which is 404. If you invoke the contract and pass the operation print, then this log method is called, which will result in the whatever interface you're using, that you get informed with this kind of information. In this case, this is just some user, and I showed him this example contract, and that's why I agreed him here. And the output of the contract would be the integer one. To display how storage operations work here, so if you want to write something to the blockchain, in that case you would have to pass the operation write. It would take the integer x and write it into a key value pair, so it is like a JSON file where you need to provide a key and some value, and the contract would just put this information onto the blockchain. And it will also notify you, so notify and log is basically the same thing, except notify can also notify you of some numerical values and not just strings. And finally, once you have put something onto the blockchain, you could read it out. I mean, the code is pretty much self-explanatory. You would call the main function with the operation read, and what happens is that I call here the get function, so you get the information read from the blockchain, and it's read out as just a byte array, and you have to do some type conversions there explicitly, and in the end I just display, you can also make a for loop, and what would happen if you use it in the user interface, that you would get, I don't know, 5 notifications. Let's say initially you put the number 10 in there, and then you would read it out, and it would print, I don't know, 20, 40, 80, and so on. Okay, so that would be a simple example. So again, when you download the NEO project, you get a compiler. What would happen is that you compile this program, it gets then translated to some opcodes, which is basically just a sequence of instructions, the instructions that the virtual machine would execute. And from this bytecode, you get also this unique hash by which you can identify the contract. And that means you can, if you're like up to it and want to write some other compilers, as has been done with Python, for example, you could take any language that compiles to this bytecode, and you could even find a program which compiles to the same program as that, I guess. Okay, sorry to bore you. If you're familiar with Ethereum, well, then you know these concepts. What you have in Ethereum would be the ERC20 standard, and there's something similar in NEO. So that's a so-called token standard, which provides a standard interface for people to interact, so that people don't have to, look up the function of, the ways in which you call the main function of each individual coin. So, for example, I suppose SPAT token and OVCO and EOS token on the Ethereum blockchain all adhere to the standard. And so, for example, if you're a wallet creator or an exchange, then you only have to implement this interface called ERC20, and then you would know how to interact with it. And on NEO, you have basically the same thing. Even the names are very similar. And this standard is called NEP5, which stands for NEO Enhancement Proposal, number 5, so there are a bunch. And here you can see what the names of these methods that have to be implemented are called if you want your token to adhere to the standards. And the nice thing is, of course, then there will be some templates. Some people will write this code for you. If you want to make a crowdfunding, for example, you would just copy-paste the template, maybe add some additional features that you want your token to be able to, or your token to do. And then you have a NEP5 compliant token that can, for example, easily be integrated on the next decentralized exchange. For a blockchain project called Amusify, which is, I guess, sort of Spotify, where people can upload music, and if you're a band and you upload your music to this website, you can be rewarded in some NEP5 token. I helped out there and modified some NEP5 compliant contract. I will now quickly go through that. So you have seen these methods before, and the way you call this contract is the same as with this Hello World example before. You have some string, I call it method in this case, and you can request different operations to be performed on the blockchain. Things like getting the symbol, getting the name of the token will be required, get the total supply of the token, and then here's the a smart contract is, really just mostly, for the most part, up until now, a series of if clauses, hardly ever more than 500 lines long. And here you have then also transfer, balance off. These are all things that are required by at5. And on top of that, Chris and I wrote this implementation where on the website of the Musify project, if you were to upvote some song of some band member, then for this operation you would be rewarded, like on some social network you get reward for actions, and this what then happens is that the website would communicate with the smart contract on the NEO blockchain, and things like reward output for your token holdings for this iNEO token would go up. And in the case of the contract, there's not only this token, but there's also a second token, which is basically the level of the user on this website, and similar to Karma on Reddit, I guess, and just a reputation on Stack Exchange. And the level would go up, and if your level goes up, then also your reward go up, and it's basically just a proof of concept. So here, when you were rewarded more than 3 times, then you would go to second level, and whenever you get rewarded, you get this and that rewarded. And the nice thing here is that once that happens, once you do the actions on the website and you get rewarded, this on the NEO blockchain, this level is associated with you, and you can, since this is a Net5 token, freely exchange these tokens, and everything is like hard-coded and independent of the Musify website, really, right? So all the money aspect is just on the blockchain, and you got your level because you worked for it, and nobody can take it from you. Okay.
We're going into situation.
We skip that. Okay, time for one question.
The last part you were talking about, would that be use case scenario, visit my Twitter account or follow me, and then you will get rewarded or whatever?
Yeah, I guess you can. So he asks if this could be translated, I guess, to some social network, for example. If
do a task, tweet this, and then.
Yeah. So I mean, in principle, the question is, can you integrate this to some website for some social network for some operation, for example, retweets or something? And yeah, nothing is stopping you. I mean, if if the website writes some middleware that communicates their services, in this case the social network, to the blockchain. That's what was happening here in this example. Then easily you can tie any operation that can be observed that users do on your website with some effect that happens on the blockchain. But of course, like in the spirit of decentralization, it must be noted that there's still some centralized aspect of it, because these people would run the social network and would communicate to the blockchain, and I did not talk about a social network on the blockchain itself where everything is automated. You can ask me later if that doesn't clarify the question.
Second question, maybe?
Okay, so second question.
I've never programmed a smart contract, but what happens if you're in the situation that you have to do something that is numerically expensive, for example, something like a matrix inversion or so? Is something like this possible on the NEO blockchain?
Yeah. I didn't mention it. I should have, I guess. idea of gas, right? I think it's even an idea of Vitalik himself. I don't know. It's an integral part of the Ethereum white paper. Is that for example, if you were to write an infinite for loop and you had a contract that goes on forever, then you could call it and have other people run your never-ending contract and get into a loop, right? Could stall them. One solution is the idea of gas, that every operation, like actually every opcode in the compiled smart contract costs some money. In the case of Ethereum, that would be Ether itself, like tiny amounts, and in NEO we have these two asset system where there's the NEO which throws dividends and gas, like the name is just the same that is used in the Ethereum white paper. Is actually the cost for you to run through these opcodes. So yes, I have actually written smart contracts where I just compute the nth power of some number and so on. But as every operation costs some money, and how much it costs, that's at the moment hard-coded and could be also in principle changed, but as all these operations cost money, if you were to implement a matrix operation, which is possible, you have seen, maybe I imported some numerics library at the beginning of the smart contracts. You could do that, but it would be super expensive, and depending on how the blockchain is set up, that's a good or a bad idea. If you were to run your own private net and do a fork of NEO and make these things cheaper, yeah, why not? It's just C#, even though, I mean, of course it runs into a virtual machine, so that's not very efficient, but it's possible. Actually, these virtual machines are Turing complete, so you can pretty much do everything. You can actually take everything, even in the smart contract, and you're good to go.
Could you give an example for something that is... Oh, sorry.
Yeah, let's talk about that.
We'll save that for the Q&A. Okay, so now we're moving on to Python smart contracts. I also did smart contracts in C# and Solidity, and my basic impression is that Python, for me personally, is extremely readable and just very easy to work with. So how many of you guys have seen the workshop stream in NEO Amsterdam? No one. Good. Original content. So, have any of you seen the NEO Amsterdam stream? Okay. That's worse. You look it up. It's a good stream. Anyway, so we're gonna do a little smart contract, which I thought was a cool use case. Basically, it's a licensing smart contract. It lets owners or addresses register products in our smart contract, and then it can hand out, the owner of that product can hand out licenses to those products for other addresses. Now, a fun use case that a blockchain would be a trustworthy component for is that users can then transfer the licenses amongst each other without having to request that to a middleman or to the product owner. So, product owner can register and license the products, and then users can transfer those licenses with each other. And it's super simple, and I will show you. So this is basically what it would look like, the structure. It doesn't look like that anymore because, as you know, when you work on something, it never ends up the way you think it does, and you build a completely different product. So you import some methods that the NEO VM can interpret, and in this case we are going to use the storage methods, which is super simple. You can get something from the storage, and you can put something in the storage, and you can delete it from the storage. Get context, I believe, is that you get it the storage item from the current block, correct? Then you have check witness, and check witness makes sure that whenever someone invokes a smart contract, you can verify basically an address or script a public hash of an address with the user that is requesting it. So more simply put, you can make sure that people are who they say they are. So they don't lie to you, and they cannot invoke a smart contract on behalf of another user if you don't incline to do so with your contract. So also in Python you have your main function, and we are going to take in an operation argument and just an arguments list. So there are some rules which I defined above here. The first argument is always going to be a sender public hash. The second argument is always going to relate to a product, and if there is a third argument, then that means that is going to be another address. So first off, we are going to check that we are who we say we are. So I always want users to provide their own address as the first argument, and then I want to check that against the smart contract, make sure that the user who is requesting it is indeed that user. And here is the fun readability part. You have the authorized function. It's going to go right here. So authorized, it just check witness returns a boolean, basically returns true or false whether the user is indeed the same address as the first argument. And then you just have if not authorized, then you're not authorized, get out. And otherwise we're just going to continue with our smart contract execution. So that's how you make sure that a user is authorized. Then we have some other common definitions, and before I do that I need to save my laptop from dying. No. Panic. NEO is crashing.
So you need some beer.
He doesn't even let me touch it. So.
That is the wrong program.
Alright, we say today, great laptop, shitty battery. We're not in Python 2.7 by the way, we are in 3.5.2. Okay, indeed the same hash of the user that is requesting the contract. Right, normally I take a bunch of hours for this, and I'm just going to put this into a few minutes, so bear with me. Alright, so license product is owner, that's that function I just described, and so if we are indeed the owner of the product, then we can put a license in there. So a license is another key value pair, and the requested license is basically a string. So the requested license, it looks like this, it's a concatenated string, it's just a user address hash plus the product ID, and then as the value we have that same user address hash. So that way we enter a unique key for that user, for that product, and then we give the user hash, supply that as the value. And then the last function, it's transfer license. So here we are going to check again if we are the license owner. So, here we are going to check if we are the license owner, no longer the product owner. So we're going to get the license for us, which is, for example, one that we wrote to with register license or license product. And then if we are the owner of the license, we are going to do that whole check witnessing over again. And then if we are indeed the owner of the license, then we are going to do some new things. And very simply said, we use the third argument, a different address, and then we remove the storage item of our license, and then we add one for the new user. And that is how transfers work in smart contracts. And the fun part about a smart contract is once it's executed, an invocation is made, it is one transaction and it can never stop halfway. So if you execute this function here, it can never stop at delete. It will always execute the whole thing. So a transfer, and the same goes for tokens and any other assets, a transfer is simply deleted from one person and added for another. And so that's basically how easy it is. You don't have to do any weird sciencey stuff to make a transfer and do a bunch of checks. Just delete it for yourself and add it for someone else. So those are the basic functions. I know I've been a little bit fast with them, so I hope you kind of got the idea of what this does. It's also on GitHub, right? So you can just take your time. You can go to github.com/deanpress/neosense. It's a play on words, like neo and license. Get it? So it uses an S instead of a C, but it's like I'll write it down for you here. Neosense. So it's github.com/deanpress. Deanpress.
But see the links at the end, right?
Yeah. Oh, right. Okay. Cool. Okay, so I'm just going to show you what this smart contract does with NeoPython. So I'm going to load up a wallet and then get my, and then I'm going to invoke the smart contract. Maybe while I look this shit up, you guys can answer some questions.
So, any more questions? Yeah, please.
How much would the smart contract cost to execute the simple example you made?
Okay, so as it's implemented at the moment, the virtual machine will run through the smart contract and compute the total cost, but then 10 gas are subtracted. So 10 gas is actually quite a bit. So at the moment, all these kind of applications are free, right? And they also transfers, as far as the core code is concerned, are free on NEO, right? And as opposed to a bunch of other blockchains, there is on purpose no financial incentive also to run a node. I mean, there are not many nodes anyway, but so this is not about charging people to use smart contracts, for example, as it's implemented now.
So, as it is right now, all contract invocations that in total cost less than 10 gas are free. So you have to have like a really complex stuff going on to actually pay for it.
Like inverting a matrix.
Like, yeah, like matrix manipulations or like infinite loops or stuff like this. That's going to cost. But like all normal smart contracts that you're gonna write, they are free to invoke.
Will this change someday?
There is a lot of discussions that the deployment fees are getting lowered from 490 gas right now to a lower amount, but nothing is fixed as far as I know.
No.
I mean the 10 gas minimum.
I don't know, there's no minimum.
No, I mean, I know what you mean, but...
yeah, there's no, like, I don't think there's much discussion about changing this at the moment.
More calibration, I think.
Yeah, I hope so, that there will be a little bit more calibration regarding costs, but the idea is that the consensus node prioritizes a service, and at the moment there are communities and foundations and companies anyway, so they...
Okay, there's no plan for gas costs for normal smart contracts.
Right.
Does that mean that sending more than 10 gas will also cost something? Sending from A to B?
So you're asking if transaction costs something, and at the moment, no, it is free. Right. So there are a few, like, of course, if you want to send something Bitcoin, it's almost unpayable, and Ethereum is like I actually pay people in crypto for stuff like editing videos and so on, and I paid I did last year I did 30-40 transactions, and so since everything mooned, I paid like 500 euros in transactions. So better to use IOTA or gas for transactions, which is free.
All right. So quick intermission. So first thing, when we open, so I have the smart contract we built. I have that in a directory which was different from the one I used before, which confused me. So the first thing you need to do in NeoPython is you build the contract, which does the same thing. It compiles the Python code into opcode that the virtual machine can interpret. So that is the actual code that will be hosted on the virtual machine, basically. So the way to do that in NeoPython is simply enter build and then the directory of your contract. You do this and you get an AVM file, and the AVM file contains the opcode. So now in order to deploy that to your private net, you do import contract, and then you go to that AVM file, and then you enter a bunch of numbers. So these are integers. They represent what your smart contract expects for input, what it will return for output, whether it needs storage, that's the true part, and then the false part is for a new feature which is dynamic invoke. It lets you, basically lets you call smart contract functions with smart contracts which do not yet exist. We'll get to that in another part of a different meetup. So, so that is how you import a contract. So we do that and we get a bunch of errors because obviously nothing can go right the first time. Wrong directory again. Let me just check.
Print the file name in the buffer print, I think.
Sorry, what?
If you scroll up in the terminal, it printed the AVM path. Here at the bottom. A little bit up. Just a little bit. Scroll up a little.
Should I just try and get the correct path? Maybe that's a good idea. I'm not gonna say I probably did something wrong here. There we go. Okay. So I still can't see what's different about the other one, but that might be a fun find Waldo thing. So we can do our contract details here. This is how the contract will be stored on the blockchain. In this case, our private chain. So we have our contract name, NEO Vienna. Our version, which is 1.0, whatever. I built this. This is my email. If you ever feel so inclined to contact me or ask me questions. Descriptions, we'll just do something like quantum resistant licensing with AI. And what do you guys want to do? Like a $1.5 billion ICO? Sounds pretty decent for a project of this scale. Cool. So then we can just deploy this. We already deployed it, so previously on this net. All right. So now we deployed our smart contract, and it returns a script hash right here. And this is the hash that we can call our smart contract with. And in order to do that, you use test invoke. In NeoPython. It shows you a test invocation, a dry invocation, and then you can actually send it as well. So we're just going to test the smart contract. So we're going to register a product, then we're going to license it to a different address, and then we're going to send it, transfer the license. So first off, I need to get to my notes, so I'm going to get rid of the display for you guys. Or not, hold on. I'm just going to deplug this. This won't take long.
It works smoother after that.
Faster for sure.
Maybe you just do one test invoke and then we move on, because there's like a lot of topics.
Yeah, there we go. Okay, you guys do one answer. Take one question or something.
Okay, so questions? Yeah.
Do you think it will come time where we can directly save files on this blockchain now, like photos or videos?
Since blockchain is a distributed data set, it's actually, I mean, kind of discouraged to have huge files on the blockchain, and there are discussions actually to pricing this a little bit higher, putting like higher fees in gas to put data onto the NEO blockchain.
File storage is coming as part of the NEO smart
Yeah.
economy.
Yeah, I mean, technically that's totally possible. The question is if you want to have this duplicated data, and there are also other technical solutions. So you don't necessarily have to use a blockchain.
But if you look up the NEO white paper, they specifically mention in an upcoming product, that's the NEO file system that provides a redundant storage of files that's on a roadmap for the NEO China team. So there is something about this that's in planning and in the white paper. Okay.
Question to that, but the data will not be stored on the blockchain, right? I think only the blockchain verifies that this is the correct data.
I think it's best to take a look at the NEO white paper. They have a whole bunch of stuff about this file storage. Then look it up for yourself. I'm not 100% sure right now. And let's continue with the Python.
All right. So we're going to just call our smart contract. So I'll show you how you do that. So once you write it, you want to test it and do all that stuff. So in order to do that, you do test invoke. Then you supply the contract hash, and then you set your parameters. So our first parameter is going to be an operation. So in our case, register product. And then we're going to apply our list of arguments. So in this case, we want to register product. So our first argument was always going to be our own address. So I got that one right here. And then the second one was going to be a product name. In our case, Internet Explorer. I know. I'm getting to that.
Okay.
I'm doing it on purpose. Okay. Actually, no. But I realize at the moment I do it. What I'm talking about is the following. This is going to not work, and you are going to spend hours figuring out why it doesn't work. And then you're going to think back to this moment, to this day, where I tell you, don't put a space there. Remove the space, and you'll have a functioning transaction. This won't work because
we need more developers for NeoPython. So.
All right, but this one is not good because I already registered Internet Explorer once. So instead, let's do Firefox. There we go. So this will register Firefox for us on the blockchain. And yeah, so that's what it's gonna do. So now we did the register product function. We have to wait a moment for it to be sent to the blockchain. So what we did is we defined register product, and then we sent our own script hash and a product ID, and then it just ran this little part here for the operation. So it checks if the product exists. So it didn't work when I did Internet Explorer because back in Amsterdam I used the Internet Explorer example. So if the product does not exist, then we put it in the storage. Simple as that. And that's what we did right here. So I think it's executed now.
Can I click and scroll
Yeah.
a little bit? So this exactly here, like a little bit up when you call the test invoke. So right here. So when you call test invoke, it shows you exactly how many operations this smart contract invocation does. Can you scroll it more to the top, to the people in the back? If it's easier to see. No, like, let's get this up here. Yeah, exactly. So here you see, before you actually invoke the method, you see like NeoPython executes this method in the local VM, and it shows you how many operations does it need. It's like 207 NEO VM operations. The result, in this case it's an integer with 1 because it's successfully registered. If it's like unsuccessful, because it's already registered, it would be 0. And then it shows you the gas cost. So you can then decide if you actually want to really invoke this or not. So this whole process shows how to deploy and to invoke smart contracts with NeoPython, and it's very easy to build on top of that. I think maybe we just...
Yeah, I'll add one more thing. These are returned logs. I did some debugging, logging in the smart contract, as you saw before here with, let's see, product registered, is the license for me or for a different user. All these things are going to be output by NeoPython when we run it. So in this case, it says, well, it basically says authorized. You have to read it from all the way there to all the way here. It says authorized. That means we were indeed authorized. It returns that because we programmed it that way. It applies for a license for me and not for a different user because we didn't supply a third argument. So it returns that whole thing. So if you want to get to debugging, I suggest you output a lot of that stuff, and then you can easily see where things are going wrong or where something's going right. So, and then there's also debugging for storage. So you put something in the storage. In this case, we put Firefox in the storage. So we see here the product name, Firefox. It's in the middle there, over there. And that's the key. And then the value is the byte array of our public hash of our user. So yeah, we're not going to get to transferring registering and transferring a license, but I think you can get the general idea. Now we can hand out a license for a user, and then that user can transfer the license to different users. So that is the smart contract, Python smart contract part. Workshop in 15 minutes. 25, yeah. Time flies when you're programming. All right. So which part are we doing? Yeah, I think we're going NEO 1 now. I think. Yeah. So just so very briefly, there are a lot of things that I just did. I excluded the part where this is not it. I excluded the part where I built the private net and tested transactions I manually tested transactions, all that stuff. There's a project called NEO 1. It's being built by Alex, the creator of NEO Tracker, and he is making a full stack solution for NEO development. It includes debugging, it includes setting up a private net instantly, it even gives you full stack starter things, basically starter kits. It can give you a smart contract, a private net, an address with all the hash, but also instantly a React front end that reacts with that smart contract. So you just have everything you need to make your web interface. I think, do I have it open here? Yeah. So this one came with a simple hello world smart contract, and it also came with this front end. So now if I just enter something here, it's going to invoke the smart contract and return the events and do all the stuff that the smart contract was programmed to do. So you can program your smart contract and your front end and everything with NEO 1. It's currently under development, so there's coming documentation and well, all the good stuff you need for real easy, smooth development. All right, I think that's... Yeah, so now we're going on with some dApps. So now that everyone knows how to build smart contracts, we're going to give you some inspiration.
Right, and I think we just try to keep it short and sweet right now and wrap it up with the existing projects and the upcoming stuff. And then we have some more Q&A and order some pizza and turn on some music. So I think, I don't know, 15 more minutes? What do you think? Or 30? Let's see. Who here is very hungry already? Alright, quite a few, so let's see what we can do. So what's up with the beamer again? Maybe this just needs a little bit.
Yeah, you got it.
All right, we are back on the screen. So, current project on NEO is now the last part. Let's start with the winners of the first year competition. It finished about a month ago, and there were 10 winning projects. And currently there's the second competition ongoing. And City of Saarland is continuously operating competitions, all 3 months basically. So I think the deadline for the current one is end of February. And then the next meeting, the news that come out, tagging it and pushing it to the subscribers, basically. So there is going to be an open research platform where people can contribute research and get rewarded based on their impact and on their eyeballs they get over a certain amount of time. It has some similarities with Steemit, where also people post stuff and get rewards after some time. It has some slight similarities with the token integration and the reward mechanisms. Right, so I hand over to Dean.
So I already said something about VDT network. So I'm building the VDT network protocol. It allows clients. It basically allows clients to connect to render nodes through applications. As I said, it's a decentralized render farm, and how that idea came to life was me and my co-founder are building an application that allows you to render visuals for music. And then you get animations and effects and all that stuff, but it takes a long time to render. It takes about 3 to 5 hours to render one video of 3 minutes. So we built a solution to automate the entire process and make it faster, and it's cloud-based. Except the cloud service increased their licensing fees for our service, for our render nodes. It increased from 1 license per server to 1 license per 4 cores. But our servers don't run 4 cores, our servers run 64 cores. So we suddenly paid a hefty amount for licenses. So the solution for that was to build a protocol that decentralizes the render process of our application, and then we modularize it so that any other application and any private enterprise solution can integrate that protocol as well. That's basically VDT network in short. Some other decentralized applications that are being built on NEO is Q-Link. Q-Link is basically a decentralized telecom provider. It already allows for a peer-to-peer marketplace for sharing Wi-Fi. So I'm not entirely clear on it, but you just look up the white paper on Q-Link and check out the website. Basically, you can provide Wi-Fi to other users. They can connect through your hotspots, and then they pay that user in tokens. They also provide decentralized telecom solutions for enterprise. There's also Zpin, which is a platform for the creative industry. Zpin comes with a whole bunch of applications. I don't think we've already seen every single one of them as well. It allows you to connect with other creatives. It allows you to register rights and handle copyright. It allows you to collaborate on creative projects, and it even allows you to do crowdfunding for your creative products or projects. Then there's Apex, which is an existing company which is now doing a decentralized implementation of their platforms. Apex is I believe it's also Chinese originally. Apex is a marketing, data activation and predictive artificial intelligence and customer relations management. So it's like a whole package that a lot of enterprises need to work with user data and do predictive analysis on user behavior, that kind of stuff. So they are doing a whole bunch of decentralization and building a bunch of things on NEO smart contracts as well. So those are some of the applications which I personally like. And now we have current and upcoming competitions.
I mean, I think we basically covered most of this. Current competitions is the City of Zion, the second DApp competition, and the Microsoft competition with the deadline in March. And then the next upcoming competition, that's for certain, is the next City of Zion DApp 3 competition, which you can expect to be a submission deadline late first half of this year, like end of May probably. Yeah. So I think we covered that in the part before already. So, how to get involved? It's very easy. The central community is connected on Discord. We had to move away from Slack. So Discord and GitHub, of course. Everything the City of Zion community is doing is open source under the MIT license. So you can reuse this even for commercial products without open sourcing your modifications. Reddit NEO is a huge community point.
We're opening a Stack Exchange as well.
Right, we are opening a Stack Exchange, and if you are Stack Exchange members and have some reputation, it would be great to get, like we are at about I think 80% of the votes that we need to get our own Stack Exchange for NEO. So if you would chip in, it would be great. And the easiest thing is just take a look at the GitHub, at the projects that are running. Perhaps if you are more front-end interested, check out Neon Wallet or NeoScan. If you are more interested in the back-end text stuff, check out NeoPython. Just clone it, go through the instructions, get it up and running, and you will feel some pain point or some improvement ideas. And just say hello and say you want to work on this, and you will get all support you need.
We're going through this, or?
No, this is just basically the almost final slide. You will find this link. This link links to a Google Doc, a public one, that has all the references and links that were mentioned in these talks and in...
We will be sharing the slides, so you can just click the link. You don't have to photograph it, I think.
Yeah, right. So we will share all this.
Easier ways to click the link.
I will put this in the meetup page and in the MetaLab wiki right after the meetup.
Right.
All right, so I think this is it. The pizzas are already ordered, so until they arrive, I think we can take some final questions. All right, first question.
If there's a bug in a smart contract, how do you update it?
Yes, this is a very good question. There is a NEP, a NEO enhancement proposal to do it similar as you do it in Ethereum, where you can have dynamic smart contract invocations, where you have one main smart contract and you can update the address of the smart contract where you are actually invoking the functions. So if you have a bug in the first one, you deploy a new one and change the address in the main smart contract. Right now, it's not like until this is implemented, it's not possible to update a smart contract without changing its address.
Right, so to give a simple example, for example, you have one main smart contract that you register, and you would call, for example, a smart contract hash, and that would have for example, the register product smart contract. So you have one main contract, it says call this other smart contract and call the register product function there. Now, if you have a problem with that smart contract, you're like, oh no, I did a typo and it's not working. How did I not notice this before paying 500 gas to deploy this on the mainnet? In that case, you can simply update the script hash using storage methods. You can update the script hash that you're calling. You can deploy a new smart contract, and then you can call the register product function on that other smart contract function as well. So you have one main smart contract, and then you can just update the smart contract that you're calling. All right. Other questions?
More questions? Just waiting for
All right. Where's the pizza?
What do you think is NEO's main advantage over existing smart contract platforms and upcoming?
All right. Do we have another? Oh, yeah. The question is, what do I think is the benefit of the NEO platform in forms of smart contract development as opposed to other platforms? Why I prefer NEO? All right. So, do we have 30, 40 minutes? So, okay, quickly said, the community is amazing.
Just compare it to the other one.
I'll answer the question, okay? If you want, you can walk up here and answer.
The same question, just put names to compare it.
Other blockchains.
Yes.
Yeah, good question.
Just you know, be creative. So, yeah, okay, I get it. So, we have, I lost my flow now, man, come on. All right, there's a great, active, lively community of developers, which is obviously a big plus because you cannot really communicate and get questions answered if there's no one to answer your questions. The second one for me personally is also that there are existing languages which you can use to work with smart contracts. So Python, for example, is just very readable and very simple, especially when you compare it to something like Solidity. Which was a big reason for me to pick NEO as well over Ethereum. And then there's obviously currently there's free invocations. I just really like the game theory behind NEO governance as well, but that's a whole different story. Now I'll pass the mic on to Nikolaj.
Yeah, well, my main point would also have been, you know, you can, as you saw, you can code in Python. So next week your mother can write a smart contract, no problem. And I personally feel that a lot of blockchain projects stall themselves with politics, and NEO is pretty much starting out. Everybody can make an impact there and shape how it's created. Like just yesterday, I think I saw somebody in course writing a compiler from Ruby, and it's very inviting. I was never active in the Ethereum community, so I take my opinion with a grain of salt, but it seems like everything's very much slow developing there, and like centralized decisions. So, but on the other hand, like I personally also don't think like NEO is the end of blockchain, right? I think there we will see a lot of innovations, and we will see what can be integrated and what will need a new blockchain.
There's also for example, the guy who's making NEO 1 is also doing a TypeScript compiler. So you can basically write smart contracts in JavaScript as well, just to show you the scope of how, how many different languages you can use.
I have one question about smart contracts. In the beginning you showed us the example with the Hello World smart contract, and there was a function where you could actually store something on the blockchain.
And in the license?
Yeah, in the license scheme as well. So if, I don't know, I'm writing an app that wants to invoke this function, what actually happens there? If this program runs on my computer, how does it send the request to the smart contract on the blockchain and tells it to store the value? Or is this something that entirely...
I mean, like to break it down. Yeah, so the question was how if you want to change the blockchain, how does it actually happen that you change the blockchain? Well, let's say you want to send Bitcoin to Chris here, then you would also let's say you have a wallet that's capable of doing all that. You would generate the code on your computer, sign it, and send it also just to the network. It gets to some nodes, the nodes receive this. Then in the case of NEO, there, like I didn't talk about the consensus mechanism at all, but they receive what you want to do, and then they assign a speaker node who broadcasts what should be the outcome. Everybody has the virtual machine. They compare, cross-compare what should be the thing that's actually going to happen on the blockchain. The Byzantine fault-tolerant algorithm is that they kind of double-check what they got from the other nodes and so on, and then they all perform this operation on their local blockchain data structure. And if they reach consensus, then this data will be shared amongst all the nodes. So all the nodes have the same data structure, and so that's what's happened. So really, the call for do some change is not that different than on Bitcoin, where you say, well, here I want to actually spend the Bitcoin I received earlier, and so you want to respend the input and do this as an output, and this request of sending from you to someone else gets also broadcasted to the network, and in that case it's just the instruction to here run this particular protocol, and that will be performed.
So basically a function call can be interpreted as a transaction.
Yeah, it's packaged in a transaction.
Okay.
Okay, more questions?
Yeah, I mean, for the cost again, I mean, we saw the total cost of the contract, but what if we call that contract 5 or 20 times in this one block? Is it then added, or is this then, how is it calculated?
So calling one contract per mock-up, does anybody want to give more technical information?
So I just want to repeat the question. It was, what happens if you invoke the same smart contract method like 20 times within one block, basically? It's a very good question. I'm not 100% sure myself. I think since all the nodes execute all transaction invocations, each would just execute them in the same order, so the outcome would be the same.
On the private net, it's reverse ordered, if you have it in the same block.
This means that the last added transactions in a block get executed first.
In Python, at least, if you do a bunch of invocations, like you do a put 1 and put 2, then put 2 will be returned first.
If you put in the same block or the same transaction?
In the same block, not the same transaction.
There's no double double invoking mechanism where it will not shoot an error. Like when you have double spending on
there's no double spending.
It's like sort of the same problem, right? So it's like double invoking, because basically you will invoke the same transaction on the same block. So it should have maybe some mechanism of shooting an error. Someone should try it.
It does, yeah.
Right.
It's executed sequentially.
It's the same problem because
it executes at least in the private net, it executes in reverse sequence.
Okay, but it's executed sequentially, so if the first transaction already consumed your balance, then the second will fail because it will not see outputs that it can use in the transaction.
But I think also it depends which parameters are to be had. I mean, if you try to transfer the license of the same person 20 times on the same second,
you can't do that, no.
Yeah, so it will be an error.
Right, I mean, one will work and the others will not.
It will not work, yeah.
Yeah. Any other questions? Please.
Yeah, you said there are 9 NEO nodes at the moment. Do you know what the kind of computing power is behind that? Are those like big data centers or are those small servers somewhere?
No, it's like big root servers with high specs, just to be on the safe side. But yeah, they are in several data centers and are just beefy root servers.
Okay, what is the process to add a new node to the...
Well, I mean, you can run your own nodes, no problem. There is from City of Zion, there's some guidelines how to set up the server, what specs the server should have to run a consensus node. But the process for community members to actually get consensus nodes up and running is not yet there. But you can just run your own normal node that just syncs the blockchain but not provides consensus. But we can add the link to the server specs and setup to the references document if you're interested. Okay, any other questions?
How do you get a consensus on off-chain?
How do you get consensus off-chain?
Let's say in this next exchange, you get an off-chain which has several hundreds of thousands of transactions, if I'm right. And how do you make a consensus that these transactions are valid?
Should probably ask Neon Exchange.
So the question was that the Neon Exchange will get a lot of transactions.
Next exchange uses off-chain.
Right.
Yeah. So actually, okay. So I actually looked that up just now. So what let's first put a disclaimer. I'm not from Next at all. I just read the paper quickly. And what they do is you need to pre-approve a certain amount of your balance for in the matching off-chain matching machine. So they